Okay, we are live. Hello, everyone. Thanks very much for joining the first fully remote Scheme and Functional Programming Workshop keynote, co-located this year with the ACM SIGPlan International Conference on Functional Programming. Thank you very much to the organizers for an invitation to speak at this wonderful event. My name is Bogdan Khumchuk. I'm a junior faculty member at the University of Chicago's Department of Medicine, section of Computational Biomedicine and Biomedical Data Science. Our department has a very rich and longstanding history of innovation in various areas of biomedical discovery. One thing you may have heard is that we have the most Nobel Prize winners associated with our university of any university in the world. But what you may not know is that the Department of Medicine is actually both the largest and the oldest department at the University of Chicago, tracing its roots all the way back to when it was first created, when the medical school began over 110 years ago. Joining me here today during this keynote will be one of my research assistants working in my lab, who is based in UChicago's Department of Computer Science. Today, we'll be talking about the vibrant place that Lisp programming has in modern academic research and pedagogy, and most of the attention will be on its application in various areas of biological data science, both from a research as well as an educational perspective. So let's get started. This talk will be split up into two parts, one given by my RA and one by myself, where we will present complementary perspectives of what it's like to work with Lisp in the modern academic system, both from a faculty research perspective as well as a student educational perspective. All the examples given will be focused on my own experiences as a PI at the University of Chicago, and before that as a postdoctoral research fellow at Stanford University. I'll talk a little bit about what it's been like running the BioLisp Foundation, which focuses on the nexus of Lisp programming and biology. I'll also talk a little bit about some of my experiences using Common Lisp to build technical infrastructure platforms for life sciences data, focusing on database programming for large-scale biological sequencing data, and its interface with natural language processing, as well as other areas of computer science. And finally, I'll highlight what else has been going on in the research community of folks who use Lisp-based languages in biological data science and some of the wonderful opportunities and unmet needs that this presents. Then I'll hand over the mic to Jonah, who will talk about what it's been like to use Lisp-based languages like Racket, Clojure, and Elm in coursework here at UChicago's Department of Computer Science. And if, of course, there's one thing that you take away from this talk, it's that Lisp-based languages and its dialects are still very much alive and well in the modern academic research and education system, at least in Division I research universities such as UChicago, which has one of the top departments of computer science in the nation, and is very well known for both its research and theoretical computer science, as well as the depth and the breadth of its educational programs offered at both the undergraduate and the graduate levels. So let's start with the BioLisp Foundation. So I'm the president and main organizer of this organization. You'll see here that we have a pretty interesting GitHub page. And you might recognize a couple of faces here in the People tab. Didier Verna, you might recognize Alberto Riva, Vsevolod Yomkin, who works at Franz Incorporated and is the creator of CLNLP, which is the main natural language processing library for Common Lisp. He's also the author of the Programming Algorithms book, just published actually earlier this year in 2020, which is the first comprehensive algorithms and data structures textbook for Common Lisp practitioners. Also in here, you'll see Arthur Gleckler, who's the editor of Scheme Requests for Implementation, and he's actually spoken at this workshop in previous years. Also, Bill Swaney is in here, although his avatar doesn't show his face. He's one of the top Clojuristas working at Apple, doing some super secret stuff that I know nothing about, but he's a good colleague of mine and good friend. Here's a screenshot of a YouTube video from one of our previous BioLisp events, where we invited Peter Karp from SRI International to come give a talk on visualization capabilities in his lab's biological pathway tools software, which includes many different complementary software programs, all written in a combination of Lisp-based programming languages. Speaking of the logo here, by the way, please note that to use not the .org extension that's shown on the screen, but actually please use the biolisp.com extension, as I forgot to renew that domain in time and ended up losing it. Unlike Google, who once lost their google.com domain for 1 minute because someone was able to buy it for $12. I wasn't able to ever recover this .org domain, but oh well. So please refer again to the .com domain moving forward if you're going to access the BioLisp website. Also, Arthur Gleckler, who I mentioned on the other slide, actually helped me film these BioLisp events as a resident videographer at Stanford University, where I was previously a postdoctoral research fellow. And before taking up a faculty position here at the University of Chicago. So if you're interested in learning more about, this talk or others like it, as you can see, there's an abstract given here for reference and any other talks like that. For instance, you're also welcome to check out Arthur's other fantastic videos on YouTube, as he is the main organizer of the San Francisco Bay Area Lisp and Scheme users group. And there's some really, really great videos there covering things from cryptography to quantum computing and beyond. A real treasure trove of good stuff I would encourage you to watch if you're a Lisper. Also, if you happen to catch one of us in person post-COVID, we'll be happy to give out one of our stickers. I know I always carry mine around, so please don't be shy and approach me. I'm very approachable and love talking Lisp with fellow Lispers and sharing experiences. I also love stickers and really miss attending in-person conferences, as I'm sure all of you are as well. As you can probably already guess from the previous slides, all the research work that I've done to date has focused mainly on biological data science, so namely bioinformatics and computational biology. A few years ago, I co-authored a publication published in the highest impact factor bioinformatics journal called Briefings in Bioinformatics, where we highlighted why we need more Lisp programming in biology. And you may recognize some of these other names in the co-authorship list. Of course, Peter Karp, whom we discussed on the previous slides, but also the legendary Eddie Weitz, who really needs absolutely no introduction. I mean, if you don't know who Eddie Weitz is, you're not my friend, but just kidding, of course. But you would really owe it to yourself to check out some of his really foundational Lisp work, like the Hunch and Toot web server, or even his most recent Common Lisp Recipes textbook that was published not too long ago. Previously, I gave a keynote at the 2017 European Lisp Symposium in Brussels, Belgium, on our Briefings in Bioinformatics publication on the previous slide. And here you may recognize another familiar name in the Lisp community, that of Jeff Schrager, who is the creator of a web-based programmable biological knowledge base called BioBike, which went to live public alpha testing in August 2003. That's a long time ago. That's 17 years ago. So unfortunately, I don't believe it's maintained anymore, but BioBike was a complete knowledge-based computational biology resource, enabling biologists to manipulate biological knowledge and data, and providing a platform for computer scientists working on methods in computational biology to develop their methods and deploy them immediately to working biologists. I covered it in detail in the Briefings in Bioinformatics review article, in case you would like to learn more about the history of that system and how it impacted future developments for the field and was a first for its time. Keep in mind that back then, which, as I mentioned, was the year 2003, the Human Genome Project was just declared completed and finished. So Jeff and his team of engineers were already way ahead of the curve in terms of creating the supply to meet the future demand in biological data science, namely in this case in genomics. In 2018, some 15 years later, I did some database work myself in Common Lisp. So in collaboration with my colleague Vsevolod Dyomkin, who I introduced in the previous slides, we had a wonderful collaboration together, one that produced a GitHub repository that's been starred 43 times to date, and that we released a preprint for on bioRxiv. So here's the preprint. Basically, if you're interested in the interface of database work and natural language processing, or NLP, I highly encourage you to read our paper, as the principles we highlighted in it are applicable far beyond just biological data science. For example, we came up with this very cool new collective intelligence concept that allows NLP-based search results to get re-ranked in real time based on user clicks, effectively adding a human component or a dimension to bread and butter NLP algorithms such as word2vec, which you may be very well familiar with. Like most good software, the idea behind BioChat came about from a personal need. So this is something I commented on about on Twitter back in 2018. I said, on a personal note, BioChat was born out of frustration of not being able to copy-paste a gene expression omnibus accession identifier, often present in data availability sections of papers that I read, into a search bar to find what other similar data sets exist out there that I should know about. And basically, that was something that was very, very useful to the community, because as we read papers, sometimes we want to compare how the data set behind that paper is similar from a metadata footprint perspective to a data set from another paper that was published. So that's what BioChat allows you to do. Unfortunately, the project ran out of funding, so if you'd like to still access the website, you'll need to set it up from scratch using the open source code on GitHub. Yay, open source. So that provides some thorough documentation of how to get set up and running. As I just mentioned, some of the novel principles we proposed in the manuscript are applicable far beyond biology. So if you're a Lisp aficionado and you want to try out some of our algorithms in your own database and NLP work, please feel free to fork our repository. For the most part, the repo, as I mentioned, it's no longer being maintained, but please do open any issues or requests on GitHub, and I will personally try to get around to addressing them. By the way, this is actually a common problem or issue, that I've seen with a lot of Lisp repos on GitHub over the years. In other words, most of them start out very strong. They live a decent software life cycle, but then practically all end up in the graveyard and they die. Something serious needs to be done about that, I think, but it's unclear yet what that solution path might look like. So I'm open to ideas. And those ideas, I think, will be applicable, to any Lisp-based languages, because I've seen this happen for Common Lisp. I've seen this happen for a number of different repositories. So moving forward, speaking of maintenance, Peter Karp's Lisp software has actually been extremely well maintained over the course of several decades, which is quite phenomenal. Here's a screenshot from our BioLisp website's recent news section. If you'd like to follow latest events happening at the interface of Lisp and biology. So as you can see, there's quite a bit of research going on in the Lisp programming world as it relates to biological data science, which is, as I mentioned, it's my lab's area of expertise here at UChicago. However, there's also quite a bit of Lisp programming going on in the educational programs here at the University of Chicago as well. So now I'd like to turn it over to one of my lab's research assistants, Jonah Fleischhacker, who is currently an undergraduate student pursuing his bachelor's degree in computer science. He'll talk to you about how Lisp-based family languages are influencing the coursework and instruction delivered here in the UChicago CS department, as well as his own experiences programming in Lisp-based languages such as Racket, Clojure, and Elm, both from a research and from an educational perspective. So with that, Jonah, over to you. Take it away.
Thank you, Dr. Homchuk. Okay, so as he mentioned, I'm a current student, and I'd like to share my perspective on the different languages that were used to introduce me to computer science. And I'll focus on three main types of introductory experiences that I went through: a CS 101 type class that introduces beginners to computer science without any previous experience at all, my first research internship and larger software development project, and finally a introduction to functional programming course. And for all three of these experiences, I'll share the language that I used and my thoughts on them from a student perspective. So my name is Jonah Fleischhacker. I'm a third year college student and I'm studying computer science at the University of Chicago. I'm not an educator or a researcher or functional programming expert, so take all my opinions critically, and I know instructors generally know better than the student, but I do hope my perspective as a student is helpful and interesting. I was born in San Francisco, and given the tech boom in the city as I grew up, I've probably taken more CS 101 type classes than I would care to admit, from summer camps to early high school classes, later high school classes, special school events, multiple college courses, self-taught online courses, and even teaching a few young students at a different summer camp. I've started from scratch probably too many times. And while this might have given me some redundant knowledge, it's also given me a pretty good perspective on the diverse computer science teaching styles and different languages that can be used. One of the defining characteristics of an introductory computer science course is the language that's used. And while ideally the contents of the theoretical class should transcend the language that's used, I do think the nuances of any particular language should also guide the curriculum, and the projects and lessons should be designed around the strengths and limitations of the language. And frankly, some languages are just better than others for an introductory class. I recently played a video game called TIS 100. You can see it on the right, and this involves solving coding challenges in a assembly-like language. And while I loved the game, assembly is cool, if this was used in my introduction to computer science course before any other programming experience, I would probably drop the class and never come back to the field. And finally, whether it should or shouldn't, the languages do inform and influence the students' decisions on which courses they want to take, or even which colleges they want to go to. So that being established, here is a chart that shows the languages used at the top 39 United States computer science departments for introductory courses. And as a warning, this is 6 years outdated, but it still does clearly show the dominance of Python and Java. And contrary to that, my experience in university started with Scheme. And then we moved on to C. In high school, they started us off with Scratch, actually a dialect called Snap, developed by Berkeley. And then we moved on to Python. And I've also taken a online course and summer class starting me off from scratch in Java. And also, it's not on this list, but I have taught JavaScript to middle schoolers, which was really not the best language of choice for a middle school class. They should just stick to Scratch and Snap in the future. So you can see that there's 5 universities that use Scheme, and the other ones are Yale, Northeastern, Northwestern, and University of Minnesota. Notably, MIT taught their intro class in Scheme for over 30 years, but they recently switched to Python, which we all know is a horrible mistake. Just kidding. So as I mentioned, my first college level introduction course was taught in typed Racket, which is a dialect of Scheme. And this was the middle path in the introductory sequence that was designed for major level students. There was, it assumed no previous computer science experience, and thus was a true introductory course compared to the honor sequence, which did require previous experience, and that was taught in Haskell. And then the non-major sequence, which you can start out if you want to be a computer science major, but you have to rejoin the major sequence, and that's taught in Python. So without diving into any language-specific decisions, there are a few obvious strengths of a language like Racket. First of all, nearly all students going into the class were unfamiliar with the language, including me at the time. And this did help level the playing field between students who had programmed before, like me, and students who are starting from square one. While a true leveling is an impossible task, it did help immensely to have such an unfamiliar language and unfamiliar functional programming in general. In addition, the decision to use Racket did help students remember that this is not simply a programming class, it is an introduction to computer science class. And the more pre-professional 121 sequence that's taught in Python is meant for those students who just want some Python programming experience. This is meant for the major level students who know that they'll have 20 more courses to continue introducing them to computer science, maybe some that might be slightly more practical. But using Racket helps keep the focus more specific and theoretical. And then in addition, some really good strengths from the get-go. Racket has really excellent documentation, and the CS department created their own documentation for the parts of typed Racket that we'd be using, which was immensely helpful. And visualizations are really simple and streamlined for beginners. Our very first project was creating a recreation of the UChicago skyline, and that was, and besides maybe Scratch, I don't think any of the other languages used in my introductory courses ever even left the command line. So to be able to get some sort of visual feedback from the very beginning was really helpful. And then also you can see in that image to the right that it's a Sierpinski triangle, a fractal, and that's a really great way of introducing beginners to recursion with an actual good visual feedback. When normally recursion is just taught with, I don't know, a loop, something that is harder to wrap your mind around. And then the Big Bang package is a package that lets you create interactive animations that interact with the visualizations instead of just creating static visualizations, and that enables the beginners to create pretty good interactive applications from the very beginning without learning too many technologies. So Racket's philosophy behind language-oriented programming also enabled the instructors to customize the language they're liking for the course. They created CS 151 core, which made a few changes. They enforced strict typing and contracts. They changed some structure names for simplicity. They removed universal equality operators, so we had to use type-specific equality. They blocked mutability. And you can see in that screenshot, that's a screenshot from one of our projects of a in-order traversal of a BSD. You can see the contract that we had to make that shows the clear input and outputs. You can see how we did polymorphism and how we tested with check expecs. And while for this class, I do believe these are really good changes. The flexibility and beauty of Racket is that any instructor can choose between changes like this, depending on the experience of students or just their individual teaching philosophies. In our class though, because of these enforced strict static types and the contracts, I did find that once I fixed all the compile errors, there were no runtime exceptions. The program pretty much always worked. And when combined with Dr. Racket, which is the IDE, and its great error highlighting, it made for a really pleasant coding experience as a beginner. Yeah, so Dr. Racket is a really easy to use all-in-one environment that comes with Racket, and it really simplifies the process of installing and using Racket for every student. Having one IDE that's shared between all students is really good for introductory course, and it lets the instructors avoid any Vim or Emacs confusion or the never-ending IDE debate. If someone has a problem, the instructor always knows what environment they have set up, and students can collaborate much more easily. And then just the features of Dr. Racket are really great. It has a built-in REPL, which runs alongside the code, and also acts as a canvas for the visualizations. And other standard features like auto-formatting, debugging, syntax error highlighting, and many more just make it an overall capable and streamlined IDE for beginners. So from my perspective, this was, of all the introductory courses, my favorite one, and also the only introductory course that used a Lisp that I took. Beyond any other class, this forced me to understand recursion and higher order functions from the very beginning, rather than teaching it on the side after already presenting more intuitive imperative solutions that I'd usually just default to. And then in addition, because of the small core library, the syntax came quicker to me than with other languages, and there's little to no boilerplate code or overhead to learn. And as I mentioned earlier about leveling the playing field, there weren't really easily referenced online solutions because of the projects that were really individualized to our class, and the visual projects rather than like coding exercises that you find in every intro CS course, and just the relatively unused language. And then finally, I gained some really invaluable experience in having to use recursion and higher order functions and implementing data structures, which most introductory classes just don't practice as much. If you look at the screenshot to the right, that is the final project for this introductory class, which is a playable version of the ancient board game Go. And I'd say of all the introductory classes I took, besides maybe the one that used Snap, this was the most interactive and visual project, which is really helpful and rewarding for a beginner to be able to start from nothing and be able to create something like this after 10 weeks. So overall, I'm really glad that the computer science department at UChicago has stayed true to its core of highly theoretical approaches to education rather than switching over to Python and Java at the demands of more pre-professional focused students. I think that this type of teaching is essential and useful, and I'm glad that they offer the I'm glad that they offer the lower level introductory course in Python for non-majors, but have still kept Racket for the middle major level students. That being said, my opinion is definitely not that of the majority among students, especially first-year students. I'd say the main challenge for the future of this class is resistance to typed Racket. I was one of maybe a handful of students in my class who actually said that they liked Racket, which seems like a low bar, but it is true. And there was a lot of pressure from parents and students to switch to a more, quote, useful language. I don't think so, but some people did. The older students and the instructors definitely did appreciate the beauty of Racket. But yeah, that was kind of it. So next, I'm gonna move on to my experience as a undergraduate intern last summer. So this was after my freshman year using Clojure. So I joined a bioinformatics project at University of San Francisco to help develop a database and web application. And we used exclusively Clojure and Clojure script. This was my first software development internship and also my first time using a functional language outside of that 151 class to build actual real world software. The creator of this project, Andrew Nguyen from University of San Francisco, he's a huge Clojure proponent. He loves the JVM integration, the advantages of any Lisp-based language. And I did find it similar to Racket and its advantages, but with a lot more flexibility and interoperability with other languages and technologies. So specifically, the project also used, besides Clojure and Clojure script, it used Neo4j for the graphical database and Kubernetes for deployment. So since the advantages of Clojure are quite similar to the advantages of Racket, I'll go over them a bit more briefly. But things like the REPL, the small amount of core functions, the speed, good error handling are just as good as Racket. Where it differs though is its overall flexibility. Clojure interacts really well with other technologies and seamlessly handled and communicated between all the other parts of the project. I found the documentation and open source libraries really abundant and surprisingly navigable by a student like me who was pretty inexperienced with diving through open source libraries and things like that at the time. But where I thought Clojure shined the most was the onboarding of the project. When I was first introduced to the project and looking through the code, I was blown away by how complex of an application was wrapped up by such compact and simple modules. There aren't any lengthy loops or object definitions. And while it was sometimes a bit more difficult and less intuitive to understand how it worked, the code was quick to sift through and really compact and well organized. This is in part just due to Andy, the project creator. He had good organizational abilities with code in general. But yeah, the language also does encourage that. In addition, due to the immutability, there were no mutable states to keep track of, which was helpful. And I know I keep mentioning it, but I have really fallen in love with the Clojure REPL. And that was really valuable for a beginner who was just thrown into this project. To be able to test hypotheses when I wasn't quite sure how the application worked and quickly iterate code for positive reinforcement was just very useful. It makes it easy to programmatically generate tests. And I do know that other languages do have REPLs. None of them have been quite as effective as the Clojure one in being integrated with the development process. It's really great to just be able to highlight an expression in the editor and then use a keyboard shortcut to instantly test that in the REPL. And if you have to change something, it updates dynamically and instantly. I read somewhere online that programming without a REPL, once you're used to programming with a REPL, is like playing live music on stage without being able to hear your instrument. And I think this is definitely true, especially for a student. So one challenge I did face in Clojure was that I found myself learning different parts of the project multiple times. Since Clojure is so good at communicating with other languages and interop, I often found myself learning the syntax multiple times. For example, Cypher is the querying language for the Neo4j database. So to integrate it with the project, I had to learn how to use the Cypher language and then how to use Cypher CLJ, which is a library to integrate it into Clojure. And similarly, to design the web page with JavaScript, HTML, and CSS, I had to learn that first language and then learn how to translate that into like the Clojure wrapper. And while I was impressed with Clojure really handling all the stacks of the project, it was sometimes frustrating having to translate everything back and forth into Clojure constantly. So overall, compared to other languages I've used for software development, I really do appreciate the utility, versatility, the community, the programming environment of Clojure, and the advantages that come with Lisp-based languages like the REPL, immutability, speed, and more were really apparent and helpful even as a beginner. It doesn't take necessarily sophisticated knowledge of programming languages to really feel those advantages. The product organization especially was really helpful to me being a beginner thrown into an unfamiliar environment, especially compared to other projects I've used that use object-oriented programming. And overall, the coding style and organization was foreign to me at first, but this could definitely be improved with more exposure to functional programming for more widespread use in teaching. But I do think having previous Racket experience was pretty essential. All right, so finally, I would like to discuss my experience with Elm for an introductory course to functional programming. So given the university's usage of Racket and Haskell in previous courses, I was a bit surprised that the instructor chose such a young language with a very specific focus on creating web browser-based applications. And while I'm not fully convinced Elm is absolutely the best choice for any intro to functional programming class compared to a Lisp or Haskell, I did enjoy the language immensely, and I hope my perspective is useful for educators or beginners who are just curious about Elm. So the course was taught online during the pandemic this past spring, and as a result, the course had to pivot a bit to focus more on project-based learning rather than lectures and tests. Lectures, they couldn't count on lecture attendance as much, and tests are really difficult to administer online. So we learned essential functional programming concepts by implementing data structures like binomial heaps, red black trees, queues, heaps, random access lists, decks, things like that. And throughout the quarter, we worked on a open-ended creative project of sort of a minimum complexity. So we had to actually work on it. And this was definitely my first university course that gave us such an open-ended project. It's a bit rare for a school like UChicago, but it was a really good way of practicing using an actual functional language to build our own software beyond like a structured university project. So moving on to its advantages, I risk sounding like a broken record at this point, but Elm also had a really excellent REPL like Racket and Clojure, and I've come to be spoiled by the joy of REPL-driven development. And while there's a bit more boilerplate than Lisp, Elm is really relatively simple. It's compact, it's immutable, and fast like Lisp family languages. It has really strong static types like Racket, which helps avoid runtime exceptions, and they actually advertise themselves as having no runtime exceptions at all, which did hold true for the most part in my experience. And overall, Elm was just beginner friendly, truly beginner friendly at every stage. While there's no set environment like Dr. Racket, the installation was simple, package manager is easy, the compiler is really fast, but honestly the most helpful error messages I've ever seen of any language I've used. And the JavaScript and HTML interop is really simple and streamlined. The so-called Elm architecture is Elm's pattern for structuring interactive applications. I found it very similar to the Racket universe/Big Bang package, but with more practical applications since it could interact with JavaScript and HTML. So you first define an initial model, which contains the state of the application, and then you create a view function, which turns that model into viewable HTML, and then excuse me, and then update lets you update your model by calling functions and commands based on messages. And then finally, subscriptions enable the program to react to external events like time intervals or messages on a WebSocket. Elm's documentation claims that this architecture was not invented by them, but rather discovered by many developers using Elm and finding this pattern in their code. And whether I believe this ghost story or not, it was definitely a useful structure for a beginning developer and helpful that the instructors could teach us this architecture and let all the students in the diverse projects still have the same general structure. And you might be wondering what type of final projects we used, because if you're like me, you might look at the quality of final projects to assess the quality of a course. And while nothing totally blew my mind, I do think our projects are pretty high quality given the circumstances of the pandemic, you know, the lowered motivation, the time constraints, just like general online learning quality. So I'll show a couple of my friends' projects in my own. So this is a COVID alert system with an interactive map, and it lets you sign up for text SMS-based alerts for your, I believe, zip code based on how many cases are in your zip code. And it sends daily alerts to you. So, you know, they're trying to help the world. That's kind of cool. Another friend of mine created a pretty cool simulation of Conway's Game of Life. You know, it has predefined states, or you can draw your own states and then watch it play out. I don't really understand it because I've never learned about this in a course, but it's cool, blobs moving around, and I appreciated it. And then I like music, so I created a synthesizer and step sequencer. Shameless plug, check it out, synth.jonadf.com. It's gaining traction. I got 2 stars from people I don't know, a whopping 2 stars, so check it out before I'm acquired by Google and have to make it public or private. And if you're curious just how Elm is structured and maybe how a beginner in Elm might write their code for a functional programming course, you can check it out, synth.jonadf.com. So overall, while I was pretty doubtful at first, I did really enjoy learning Elm. I do think it was a great introduction to functional programming, especially for a project-based class like this. I do know that a Lisp family language or Haskell also would have been great for different reasons, but for the purposes of the pandemic, in a project-driven class, Elm was a really easy to pick up language that really holds your hands throughout the from installation to a really good open-ended application that you can create. And ultimately, it helped me create a fun final product that I can host on my website and show to employers. So overall, in this presentation, I covered 3 different scenarios for introductory languages. First was a CS 101 style class that teaches based on no programming experience beforehand. And based on my own experience with many of these types of classes and many languages, I do fully believe that Racket had the best balance of development environment, simplicity, great documentation, integrated visualization, and instructor customizability. But the main downside was fewer practical applications. But I don't think this is enough of a detractor to rule against using it. I think it was overall a mistake for MIT and other universities that have transitioned to Python, and I'm glad that UChicago has held steady in typed Racket. The second focused on languages for an educational internship that helps inexperienced students work on larger software projects. In my case, I was a big fan of Clojure for the REPL, for the project organization, and the other Lisp family language advantages. And while generally student interns are just thrown into whatever project they can get, I would recommend Clojure for an early level software development course or just a collaboration among students, as long as the students already have some experience with functional programming beforehand. I had the advantage of starting out with Racket, but not everyone has that. I think jumping straight into Clojure without having ever learned Racket would have been much more difficult. And then finally, for an introductory functional programming course, I believe that the language of choice really does depend on the material of the class and the pedagogical philosophy of the instructor. And since our class was taught online, our class was more project and homework heavy rather than lectures and tests. So for that purpose, Elm worked beautifully, and I recommend it to beginner developers who want to use functional programming to make a simple web application. But it has, it's really customizable and open-ended. It's not, even though it's simple and holds your hand, it doesn't limit you. And finally, I would like to just acknowledge my own bias and preferences. I clearly appreciate and enjoy functional and Lisp-based languages, likely more so than the average student. And I would not need to give this talk if there was a definitive one-size-fits-all language that should be taught to everyone. But I do stand by my opinion that these languages are underrated tools for teaching. And I feel really lucky that my professors and colleagues have introduced them to me, and people like Dr. Homchuk are still continuing to use them and really helping me realize that Lisp family languages are here to stay. I do fully trust the pedagogical abilities of universities that choose not to use Racket or Scheme, so I don't mean to attack them or say that they're making the wrong decision anyway, but I still think that they're a bit underrated. And finally, thank you so much to Dr. Homchuk and the organizers of this conference. It's really an honor to speak today. Thank you.
Thank you very much, Jonah. We will now open it up to questions that any of you may have. Thank you very much.
Thank you. Thank you everyone for watching, and special shout out to my professor and TA, Ravi and Justin, who were helped me learn functional programming, and now they're here to watch me present on it. So thanks for coming, guys.
Thanks, Jonah. That was really awesome.
I just have a couple of comments. You can hear me or not. One of the things is I've been teaching Lisp since '66, and that's a long time. And I have to say, it's great to hear a talk like this. It is such a fantastic experience.
Thank you.
And I appreciate the little ad on the logo, which is on the cover of one of my Little Lispers before Scheme took over the world. Scheme and then Racket, of course. But what a wonderful experience. I cannot tell you, I'm just overwhelmed. Not only did I believe all this stuff for so long, it's almost embarrassing, but Matthias Fellheisen was one of my students. And of course, he's responsible for making sure that Racket was built. I'm not sure what percentage, but it was quite a very good talk, and I'm glad I was rested. See you all.
Thank you.
Thank you very much. Thank you, sir.
So I have a question. You mentioned using functional languages in your introductory courses. Is there much use of functional languages in your more advanced courses? And if not, what do you think is missing for that to be a good idea?
Well, I think there's absolutely use in more advanced courses, but I don't know if I can really speak on that because I only just finished my second year, so I've really only taken the introductory courses. But yeah, there are definitely more classes later on in the programming languages, sequences and everything that use it.
Yeah, so I actually taught a reading and research in computer science course a couple of quarters back. We have a quarterly system here at the University of Chicago instead of a semester-based system. We were using Haskell for a lot of the stuff that we were doing, but what's nice about the really advanced CS courses offered here is that they give so much freedom to design the curriculum how you want to design it. So the instructor usually has, so my official title at the university here is instructor of medicine. So I do, you know, moonlight at the CS department. Like I mentioned, I taught the reading and research in computer science course. But that's because I have a, you know, very interesting background in doing a lot of CS work in my my previous history. So what's nice is UChicago really gives you a lot of flexibility to do what you want, and actually also bring in the students that you want. So I remember teaching, there was a course a couple of quarters ago where I literally had one student in the class. And we did research. So we basically turned the entire curriculum and tailored the entire curriculum around that student. And I'm actually really proud of that student in that course because at the end of the day, that student went on to become a software engineer at Uber Technologies. So she was a very, very talented young lady who did some really extraordinary work throughout her entire major here in computer science at the University of Chicago. But just, you know, getting a chance to work one-on-one with a student like that and tailoring the curriculum around that specific person was really cool. And I'm sure there's other instructors and assistant professors and associate professors here at the University of Chicago who have probably done something similar, you know, both in the bio department and the medicine department and like myself in the CS department. But as far as other functional programming languages and other courses, I'm sure there are, there's a similar level of flexibility and built into the syllabus and how we deliver the instruction of those courses.
I have a question for Jonah. Can you hear me?
Yes.
Yeah, okay. So I noticed that you mentioned the video game TIS-100 at the beginning of your part of the presentation, and that's pretty cool because I'm pretty sure that most of us are interested in this kind of games because they are video games, right? You don't go and take documentation of an instruction set architecture and just read all the pages and play with assembly just for fun. It's a lot more fun when it's labeled as a video game. And at the end of your presentation, you say that you're not like the average student of your class because most of them didn't really appreciate the course on functional programming, right? And I think that's learning functional programming is essential today, because I just tell you a quick experience I had a few days ago. I tried to do some web development, and I didn't do that for years. And I just realized that everything is functional programming on web now. Like, it's asynchronous function everywhere, callbacks, continuation, passing style, and everything. So I was wondering, what's your opinion? Do you think that if they take a course on functional programming that is labeled as a video game, they would be more interested in this course? I mean, not only label. Of course, you have to have some characteristic of video games, like scores or ranking,
Right.
or I don't know. Yeah.
I mean, I do think that the educational ability of video games is really high and possibly untapped in the computer science world. And I mean, there's tons of different fields that games have been used, online games, like, I don't know, just even like games built into Quizlet for learning real life languages. So yeah, a game like TIS 100 that was more focused on functional programming, or actually, I've played a few games that sort of introduce you to computer science, like Human Resource Machine. And yeah, if it was like tailored more specifically around a course, I do think that's a really great way of sort of tricking students into having fun while learning.
Yeah, I second that opinion, absolutely. I also think that games are a very highly sought after sector. So students that go through a CS educational system, either at the bachelor's degree level or the master's degree level or PhD level, very many of them want to actually create a career in video game design and engineering. So I know how, and I know how competitive it is too. So and plus, it's one of those sectors where they really overwork people. I think the philosophy is sort of like, everybody wants to do this. Your job is technically also like your hobby. So if you're not, putting in, 12-hour days programming, this amazing video game, then there's someone, actually not someone, but a whole line of people outside waiting for you to sort of vacate your spot and come in and do it in your stead. It sort of creates a little bit of an unhealthy work-life balance. In that specific, area of, job employment. But I know for a fact that, video gaming is a very highly sought after sort of, market segment for job opportunities. So integrating it sort of, organically into the educational system and bringing students into the fold that way, and getting them, introduced to some of these concepts and other things, I think is very valuable from a pedagogical point of view.
Mm-hmm. Thank you.
I think we have another question here from Julia Bilyakova. What is your opinion on typed versus untyped languages for introductory courses? Based on the talk, it seems that the curriculum is very much on the typed side. Jonah, I'm going to pass this one off to you. I have a couple of comments too, but let me hand this one over to you first.
I don't have that much experience. Well, I guess if you count Python as more dynamically typed, I definitely prefer the strict typing of Racket. But that's a personal preference thing, and I can't speak for everyone else. But it just like when you're learning what the different types are at the very beginning, then it's so helpful just to be able to declare and be strict in your contracts of your functions, what's going in, what's going out, what type's turning into what other type. So yeah, I do have a pretty strong opinion that introductory courses should have strong typing.
Yeah, I think also like in the real world, right? Like when you're shipping software, when you graduate and get a job, you're probably working with very large code bases, and of course, typed languages make a lot more, sense when you're shipping, a product that has hundreds of thousands of lines of code. So I think from a pedagogical perspective, being able to introduce students early on in the game to working with typed languages makes that transition a lot smoother than, for example, starting out with Python like the students at MIT are, and then having to sort of shift mental gears when they get into a C++ code base on their first job at Google. I think that that mental sort of shift transition and how you're thinking about your code and how you're reasoning about the underlying algorithm and data structures makes it quite a big difference. So I'm all for using type languages, in introductory courses here. Also, Julia says, I wonder if you tried untyped and switched or started with typed in the first place. So Jonah, do you have any thoughts on that?
You mean in my life or within the context of one course?
Probably either or, either in your own personal experience as a research
Yeah,
engineer.
I'm trying to think back to like my very first learning about types. I don't know. I guess Python was probably the most like influential of my first experiences. And yeah, I definitely had a lot of like type errors from the very beginning. And it's much easier to go from strict typing and that mindset to the other than to go from not really caring or paying attention that much to types to like all of a sudden having to work with a lot of with types, with strong types.
Yeah, I mean, I see like how popular TypeScript is getting these days, right? So, I mean, there is a fundamental, set of reasons for why that's catching on so much in the software engineering community. So it's sort of indicative of, I think, how we should approach the the education of the next generation of computer scientists. I think that if we can prepare them for sort of taking that next step after college or after their master's degree or their PhD, I think putting them into not just sink or swim, throwing them at the wolves, but sort of having the educational system sort of facilitate that. Like Jonah, you mentioned the pre-professional focus, right? Like how we started with Racket, instead of like a language like Python, right? At the same time, when you think about the long-term implications of a really solid sort of theoretical computer science-y perspective on some of these concepts, they do translate over quite nicely for when you actually go get an industry job afterwards, or even if you decide to stay, of course, in the academic system, pursue research. Like as I mentioned at the very beginning of the talk, University of Chicago's main strength is theoretical computer science. That's compared to other universities out there, that is our main area of focus in the CS world, and we're maybe even like the top university for theoretical computer science, although I'm not as aware of other places and other universities in the ecosystem. But theoretical computer science is a definite strong suit of ours, and how we it guides how we develop our curriculum and how we teach our students. Any other questions?
Okay, thank you for that talk.